video I'm going to show you how to connect a heated grip to your motorbike, or the method can be used for any other accessory like USB charger. This is extra accessories for the motorbike. Now we are in a December time and heading for the winter. The cold conditions start. It's very cold, you know, and I use a motorbike every day to go work, come back, you know. If you are a rider, you know it's not a pleasant feeling, you know, to be on a bike at a cold condition, particularly when the weather is less than 10 degrees. It's not nice. Although I have a good gloves, still after riding for half an hour, still my finger feels cold. So I thought, like, alright, better to put some heaters on the bike. So yeah, basically a while ago I ordered a universal heated pad. If you don't know it, that pad is like a piece of plastic with some element into it, which is you can wrap it around your grips, and it's connected to your battery, and it heat up your grips, and if you warm up your palms, you know. It's quite a nice thing, and it's very cheap. It costs maybe £6-7. Or you can go for the better things like heated grips that it comes with the controller, and they warm up a lot more, and but those are slightly expensive, like 50-60 pound quid. But for this project I'm gonna use Arduino and OLED display to display the outside temperature, and use Arduino to measure the heated grip temperature, and also command to on and off those heated pads, because I don't want those pads to be on all the time, because they drain lots of current. So it's better to have some control on them. It's not a big deal. I mean, if the bike is on, it supplies enough current, so the battery not going to be flat. But this is the project. I like to make it quite fancy, you know, to go for programming, you know, make it like quite interesting. So that's for this project. I ordered an I2C OLED display, one Arduino Nano, one converter, because I don't want to connect my battery directly to the Arduino Nano, because Arduino Nano is very sensitive, and the bike, the battery has lots of amps, so there is a possibility to damage the Arduino. So it's better to use a converter and reduce the volts and amps. Yeah, and I also gonna design some box, and to place my parts into the box, because the parts gonna be on the bike. You know, we ride through the rain, we're gonna wash the bike, so we don't want to water damage our parts. And I have my 3D printer, and I use the SolidWorks to design the parts. So let's go for the sketch, and I explain slightly, you understand better what I'm about to do. Okay, and here I have two sketch. One is the really basic, and this is a way if you don't want to use, if you want to turn on an accessory, let's say your USB charger, and in most of the case just people connect it directly to the battery, and they add up a switch on. They can use the battery at any time, and sometimes they forgot to switch off, and the current continuously used by the consumer or the USB charger and the battery gonna be drained, and basically you end up with the flat battery. So what I use in this circuit, we use a MOSFET IRF520N. That's the type of the MOSFET, and it's really cheap. You can get 5 for maybe £2-3, or maybe cheaper if you order it from China. So what it does, when you turn on your switch, the MOSFET has 3 pins on, and it calls GDS. G stands for gate, D stands for drain, and S stands for source. So what it does basically, when you need to find out a wire that has, when you switching on, it supplies some currents, and when it's switching off, that current's gonna end up. So when you're switching on, it doesn't use this current. It acts like a command. So in my bike, I use the gate pin to the positive wire that goes to the rear lamp. So when I switch on, so it says, it sends it turn on my rear light. So in the same time, the current goes to the MOSFET. So the MOSFET knows the switch is on. So what it does, it connects these 2 pin, drain and source, together. So from the battery, a positive goes to the USB charger, and the negative comes to the drain, and from the source pin backs to the battery. So when the switch is on, it kind of knows the switch is on. It doesn't use the current. It just kind of like a command. Is like it give a signal. Okay, the switch is on. Now is the time to connect to let the USB charger get on. So when the switch is on, basically the circuit is connected, and it acts exactly like a switch, and that's it. So this is the first method you can use for any accessories like USB charger, heated grip, light, any other. Maybe you want to add up some, I don't know, a stereo or whatever, you can use this. You don't need any more some fancy stuff. The second sketch. Okay, in second sketch, the difference is I use Arduino Nano, and I use 2 MOSFET. In the first one, when the switch is on, it switch the USB charger, or in my case is a heated grip. It's connected to the battery, so it allows the current to flow. So in second sketch, which is here, what it does, when you're switching on, the current flows toward the converter, because the Arduino Nano is very sensitive, and the motorbike battery has lots of amps. You might damage the Arduino, so I thought like it's better to use a converter. And what converter does, basically it supplies 7 volts to the Arduino. Arduino is connected to the thermistor, so it measures the temperature. So we program it, and we said, okay, when the temperature is less than 20, turn on one of the pins, pin 10, pin 11, one of the digital pins, and when the temperature is greater than 30 degrees, turn that pin off. So what that pin does, basically it commands to the MOSFET, and again the MOSFET connects the USB charger or heated grip to the battery. So again, basically what it does, it allows the current flow through the consumer. So basically at the first one, switch, when you turn it on the switch command the MOSFET to switch on and off that your accessories. But in the second one, when you're switching on, basically what it does, you are giving power to the converter, and power feeds the Arduino, and Arduino send a command to the MOSFET, and the second MOSFET basically allows to current to flow to your USB charger or heated grips. And it's really basic. I placed my DC converter here, and also the MOSFET is next to it, and I run the cables that connect to the battery from underneath. This wire goes to the battery, and also the wire that coming from the other wire that coming from the DC converter goes all the way from underneath the tank and comes here and there. So basically I'm thinking to place my OLED display, the box, place it right here. I need first to connect this wire to the rear light. So the rear light has two contacts. 3 wires goes to the rear light. 1 is negative and 2 for the light and the brake light. So the light that is always on, I'm looking for that wire. .39. So because the light is on, they consume current, yeah, and it reads less. So I need to add slightly wire into this and connect it to this one. And that's a cap, and these coins act like a heat sink, but I don't think so. These things runs hot. Just in case, if it goes hot, it transfers some of the heat out. This is the part I designed for placing my display and the controller at the front of the bike. There is a slightly wobble into it. I'm probably gonna add some glue so it doesn't allow it to play much. I wrapped up the heated pads on the grips and placed my thermistor right here, and it goes to the microcontroller, and this wire also goes to the MOSFET, which is here inside the box, to the gate pin, and these two black wire is between the negative of the heated pad and goes to the battery. And we got two wire here, one coming from the converter for powering up the Arduino, and the other one for powering up the heated pad. When it reach to the 45, it's turned off, and it comes to the 20 and it turns back on again. Let's see, does it work or not. And as you can see, there is two temperatures on the display, and the top one shows the out temperature, which is about 10 degrees, and the bottom temperature, it shows my heated grip temperature. It goes 38, is around 38. I need to rev up to warm it up. That's 45. Is a stop for 10 seconds, and what it does basically now is turning off, and the temperature comes around 20, and it turns back on again. Now it's less than 20. It's gonna turn back on again and rises to and as you can see, the temperature is again rising.